So in this video, we're going to talk about how to formulate systems of inequalities from graphs. So what we're going to be doing today is going backwards. We're going to be looking at a graphed system of inequalities and then writing the inequalities that it represents. So to do this, we're going to start off by counting the number of boundary lines of the region to determine the number of inequalities in the system. Then we're going to pick a test point xy that's in the shaded region representing the solutions and use it to test all of the inequalities. Then we'll write the equation of each boundary line in y equals mx plus b form and determine the inequality sign of each boundary line using the test point. Then we'll repeat steps 3 and 4 for each boundary line, and we can always remember check our system with Desmos. So let's start off by reviewing how to write equations of lines in y equals mx plus b form. So remember, what we're going to do is we're going to look at the graph of a line and we're going to first identify the y-intercept, which is where the graph crosses the y-axis. So that y-intercept is going to tell us the value of b. So in this case, we can say that b equals -3. Then we're going to pick another point on the graph and use that to figure out the slope. So for example, if I pick this point right here, because remember, I want to pick points that have integer coefficients. And so you can notice that from here to here, I'm going to trace out a path. So I'm going to go right 2, which is going to be +2, and I go up 1, which is +1. Remember that slope, which is m, is going to be the change in y divided by the change in x. So the change in y, you can see here I have +1, and then I go right 2, so that's going to be over 2. So if I write the equation of this line in slope-intercept form, it's going to be y equals 1/2 x minus 3, right? Because I can plug in 1/2 for m and -3 for b. So now let's try writing the equation of this second line. So notice that it has a y-intercept at 5, so I can say that b equals 5. Let's pick another point on the line and use that to calculate slope. So if I draw a path going between these 2 points, notice that I will go down 1, 2, 3, so -3, and I'm going to go right 1, so that's going to be +1. So the slope is going to be -3 over 1, right? Y over x. So -3 over 1 is just -3. So the equation of this line is going to be y equals -3x plus 5. So remember, we can also write equations of special lines. Remember, we'll have horizontal and vertical lines, and those kind of lines will only have one variable in them. So a horizontal line will look like our first graph, and it will have 0 slope, and so it'll be a y equals equation, because every point on this line, it has the same y coordinate. So notice that this line passes through y equals 3, so that's going to be the equation of this line, y equals 3. A vertical line, which goes up and down like this, is going to be an x equals equation, because every x coordinate of every point on this line is going to be the same. So this line goes through x equals -4, so that's going to be the equation of this line. So remember, when we're talking about inequalities, we know that the sign determines the type of boundary line. So if the inequality sign is a less than or a greater than, we have a dotted line. And if the inequality sign is a less than or equal to or a greater than or equal to, it's going to be a solid line. So remember, also the shaded region of an inequality can be determined by a test point. So we can use a test point like 0, 0 as long as it's not a point on the boundary line. So here you can see we have the graph of y is less than 2x plus 1. So I could test 0, 0 to determine where to shade on this graph. Because remember, 0, 0 means x equals 0, y equals 0. So if I plug that in, I get 0 is less than 2 times 0 plus 1, which tells me that 0 is less than 0 plus 1, so 0 is less than 1 is true. So that's what you can see here, we've shaded towards 0, 0. So now here we have the graph of y is less than 1/3 x minus 4. So let's test the point 0, 0, which tells us once again that x is 0, y is 0. So we have 0 is less than 1/3 times 0 minus 4, which tells us that 0 is less than 0 minus 4, so 0 is less than -4. Well, that's false, so that's why you can see here that we've shaded the part of the graph that's away from 0, 0. So let's put this all together and work on problems where we're going to be writing the system of inequalities that's represented by a graph. So the first thing to do is to look at your graph and count the number of boundary lines that you have. So you can see here we have a triangular shaped region. So we have 1, 2, 3 boundary lines, okay? So that's going to tell me that I need 3 inequalities to represent this system. Okay, so I'm going to number the lines so that you know which one that I'm talking about. So I'm going to start off with this line right here. I'm going to call that inequality number 1, okay? So the first thing to do is to pick a test point that's in the common shaded region, and we're going to use it to test all of our inequalities. So I'm just going to pick this point right here, this point 1, 3, and so that's going to be x and y anytime I test any of my inequalities. Okay, so now that we have this boundary line that we want to figure out, let's figure out the equation in y equals mx plus b form. Remember, m is the slope, b is the y-intercept. So if I look at the graph of this line, I can identify the y-intercept, which is going to be 4, right? So I have a b that equals 4. Now let's figure out slope. So I'm just going to pick this point right here, and then I'm going to use these 2 points to identify the slope. So notice that between these 2 points, I go right 1 and I go up 2, okay? So my slope, my m, is going to be y over x. So that's going to be plus 2 over plus 1, which is just equal to 2. So my y equals mx plus b is going to be y equals 2x plus 4. Well, I'm not writing equations of lines though, right? In this problem, I actually want to write inequalities. So what I need to do is I need to change this equal sign to an inequality sign. So since I don't know that inequality sign, I'm just going to use this box to represent that I don't know it, okay? So I have y and then something 2x plus 4. So remember, we have 4 possible inequality signs, right? But I can kind of help myself out if I look at this line right here. Notice that it's a solid line, okay? Since it's a solid line, I know that I have to have a less than or equal to or a greater than or equal to. So now I just have to narrow it down, okay? So I'm going to do that by using this test point right here that I started off with. So I'm going to plug that in for x and y and see what happens here. So I have 3 and then something, 2 times 1 plus 4. Okay, so 3 and then something, 2 times 1 is 2 and then plus 4. So 3 and then something, and then 2 plus 4 is going to be 6. So we know that 3 is less than 6, so that's telling me that this should be a less than or equal to. Okay, so that's how I'd write this inequality. Y is less than or equal to 2x plus 4. Okay, so I have the first inequality in my system. So now let's go ahead and work on the other 2. So let me try this one. I'm going to call this inequality number 2. Okay, that vertical line going right there. So I'm going to start off by figuring out the equation of the line. Well, if it's a vertical line, remember that it's a special line, right? So we have that mnemonic box, the second half of it. So a vertical line is going to be an x equals equation. Since this line passes through x equals 2, it's going to be x equals 2. Okay, so now let's change that to an inequality, and I'm going to use that same test point that I started off with to figure this out. So we have x something 2, and then we know that our test point gives us an x value of 1. Okay, so 1 is what compared to 2? Well, let's think about narrowing down our inequality signs, right? If we look at this line, notice that it's a dotted line. So I know that I have a less than or a greater than sign. If I look at 1 and 2, well, I know that 1 is less than 2. So this is going to be the inequality, x is less than 2. So now for the third inequality. Okay, so inequality number 3 has this boundary line that I've numbered number 3 right here. So now let's figure out the equation. Well, notice it is a horizontal line, okay? So from our mnemonic, we know that horizontal lines have a y equals equation, right? And notice that this line goes through y equals 1. So it's going to be y equals 1. And I'm going to go ahead and change that to an inequality, right? So y something 1. Well, our test point gives us a y value of 3. Okay, so 3 is what compared to 1? Well, let's think about the possibilities for the signs. So notice that this is a solid line, okay? So it's going to be a greater than or equal to or a less than or equal to. 3 is bigger than 1, so we're going to say 3 is greater than or equal to 1. So this inequality is going to be y is greater than or equal to 1. So now we have all 3 inequalities in our system, right? I'm just going to highlight them. So we have x is less than 2, y is greater than or equal to 1, and we have y is less than or equal to 2x plus 4. So what we can do is actually put all of these together and graph in Desmos to verify that this is the correct system. So now I'm going to use Desmos to help me verify that the inequalities we found were correct. So remember, our first inequality was y is less than or equal to 2x plus 4. And then our second inequality was x is less than 2. And then our third inequality was y is greater than or equal to 1. Okay, so if we look at this and we look at the overlapping shaded region, notice that it is matching the one that we had originally, right? So here's the first inequality, and then the second inequality overlaps here. And then when we add in the third one, we get that same triangular shaped region. So we can just go ahead and write our system of inequalities all together. We have y is less than or equal to 2x plus 4, and then we have x is less than 2, and we have y is greater than or equal to 1. Okay, so now let's try this example. So let's once again write the system of inequalities represented by this graph. So we're going to start off counting and see how many boundary lines that we need. So we have 1, 2, 3, right? Because we have this triangular shaped region. So we know that we need 3 inequalities. So let's go ahead and start figuring out what they are. So remember, I need to find a test point, and I kind of like this point right here. You can see that the 0.20 is included. So I'm going to use that because I kind of like using points where we have 0 for one of our x or y values. So I'm going to use that point, and let's go ahead and let's start with this boundary line right here. Okay, so I'm going to call that number 1. So let's write that equation in y equals mx plus b form. So notice that that intersects the y-axis at -1, so we know that our b value is going to equal -1. Now let's figure out the value of m. So I'm going to pick another point on that line, and so the second point I'm going to pick is going to be here. So if I draw a path between these 2 points, notice that I'm going to go right 1, 2, 3, so plus 3, and I'm going to go up 1, 2, so plus 2. So my m is going to equal positive 2 over 3. So that's going to give me the equation y equals 2/3 x minus 1. But like I said before, we're not looking for equations, right? We're going to say y and then something 2/3 x minus 1 because we know we're looking for inequalities. Well, if I look at this line, notice that I have a solid line. Okay, so since it's solid, I'm going to have a less than or equal to or a greater than or equal to sign. So let's use our test point to help us figure this out. So if we plug in our x and y values, we get 0 and then something 2/3 times 2 minus 1. Okay, so that's going to be 0 and then something, and then 2/3 times 2, well, that's 2 times 2, which is 4, over 3 times 1, which is 3, right? So 4/3 minus 1, and so remember, that's going to be 0 and then something like 4 over 3 minus 3 over 3, which means that we have 0 and then something and then 1/3. Okay, so 0 is less than 1/3, so we know we're going to have 0 is less than or equal to 1/3. Okay, so this is going to be the inequality y is less than or equal to 2/3 x minus 1. So now let's go ahead and figure out the second inequality. So I'm going to do, let's do this one right here. Okay, so first we start off by figuring out the equation of the boundary line in y equals mx plus b form. So notice that I have a y-intercept at 2, so b equals 2, and let's pick another point to find the value of m. So if I draw a path between these 2 points, notice that it goes down 2 and right 1. So since we do y over x, I have -2 over 1, which equals -2. So what we need to do now is write the equation in y equals mx plus b form. So I have y equals -2x plus 2. Okay, so when I change that to an inequality, it's like y something -2x plus 2. So remember that test point we were using was 2, 0, where 2 is x and y is 0. So let's go ahead and plug that in, and also let's use the shape of the line to figure out which inequality. So you can see I have a dotted line, so I'm going to have a less than or a greater than sign. So I need to figure that out using this test point, so that tells me 0 and then something, -2 times 2 plus 2. So I have 0 something, negative 4 plus 2, which tells me 0 and then something. Negative 4 plus 2 is negative 2. Well, 0 is bigger than negative 2. So this is going to be the inequality y is greater than negative 2x plus 2. Okay, and now finally we need to work on the third inequality. And so this third one is right here, and this is a vertical line. Okay, remember that vertical lines will have an x equals equation, right? So this is going to be x equals, and it passes through 3, so it's going to be x equals 3. But remember, I need an inequality, so it's going to be x something 3. Since it is a solid line, I'm going to have a less than or equal to or a greater than or equal to sign, right? Those are my two possibilities. If we plug in the test point, we have 2 and then something 3. So we know that 2 is going to be less than or equal to 3. So this is going to be the inequality, x is less than or equal to 3. So now we have our system of equations, right? We have x is less than or equal to 3, y is greater than negative 2x plus 2, and we have y is less than or equal to 2/3 x minus 1. Okay, so now let's use Desmos to help us check our answer. So I'm going to go ahead and type in our system of inequalities. So we have y is less than or equal to 2/3 x minus 1. And then our second inequality, which is y is greater than negative 2x plus 2. And you can see here, there's our region of overlap. And then we have our third inequality, which is x is less than or equal to 3. Okay, and you can see that where all three overlap, it does match that triangular shaped region that we had originally, right? You can see it's right there. So now that we've verified everything, let's go ahead and write our system all together. So we have y is less than or equal to 2/3 x minus 1. And we have y is greater than negative 2x plus 2. And x is less than or equal to 3. Okay, so that's our system of inequalities. So now you can go ahead and pause the video and try writing this system on your own. Okay, so here is the system of inequalities that I found. Y is less than negative 2x plus 3. X is greater than or equal to negative 4, and y is greater than 1. So I started off with this first inequality right here that has that dotted boundary line. I found the equation in slope-intercept form because the y-intercept was at 3 and the slope was negative 2. So I have y equals negative 2x plus 3. And then I turn that to an unknown, mystery inequality sign. I do know that it's a less than or greater than because I have this dotted boundary line. I also picked the point negative 2, 4 to use as my test point for all of my inequalities. So when I plugged that in, I got 4 and then something 7. I know 4 is less than 7, so I turn this into the inequality y is less than negative 2x plus 3. Then I found the second inequality. That is a vertical line, so I know it's going to be an x equals equation. It's x equals negative 4. So when I plugged in the x from my test point, I had negative 2, and I know that negative 2 is greater than or equal to negative 4. So that's how I got x is greater than or equal to negative 4 for my second inequality. And then for my third inequality, I noticed that I had a horizontal boundary line, so that's going to be a y equals equation. Since it passes through y equals 1, I know that that's going to be the equation of the boundary line. Then I turned it into an unknown mystery inequality box, and I know that since it's a dotted line, it's going to be a greater than or a less than sign. If I plugged in 4, which was my y for my test point, I got 4 is greater than 1, which is how I got y is greater than 1. And here's my graph in Desmos, which we can use to verify that we did find the system correctly, right? So you can see these two regions overlap here. And then when we add in the third inequality, you can see that we have that triangular shaped region that matches what we had in the original problem. So remember that you can write the system of inequalities represented in a graph. You just have to start off by counting the number of boundary lines to determine the number of inequalities, and then use a test point and the rules of dotted or solid lines to write each inequality in y equals mx plus b form.